Hello pre-calculus students, this is Mr. McAllen and today we're going to talk about the 12 basic functions. Now when you see the 12 basic functions, you need to be able to graph them or sketch them on a basis so that you understand what the function looks like and you can answer the following questions. From your sketch, can you determine the domain for each function? If the function has symmetry, odd or even or neither, can you discuss boundedness for that function? Can you discuss whether the continuity of that function, for instance, does it have a removable or infinite discontinuity, or maybe a jump discontinuity? And can you determine for that function if you have horizontal or vertical asymptotes? So when you work through this lesson today, and when we go over the video, you should copy down into your notes the 12 basic functions. The first one we're going to start off with is the identity function. So pause the video and draw the basic sketch. Remember, it's just the function y equals f of x, f of x equals x. And, for instance, the domain you should write down is all real numbers. You would want to talk about continuity, and you would say this is continuous everywhere. You'd maybe want to talk about its symmetry, and its symmetry would be odd symmetry. You might want to talk about if it has a horizontal or vertical asymptote, and the answer would be no asymptotes. So what you'd like to have is possibly make a flashcard out of this function so that you could routinely drill on whether you know the function. If I say the identity function, y equals f of x, if you see a graph, and be able to answer all these questions. All I'm going to do is I'm going to move to the next function and write out the next few things, and then you should copy them down in your notes. The next function is the squaring function. Now this is just y equals x squared. The domain, all real numbers. It's a continuous function. It's defined for all x and has no breaks or jumps or skips, so it's a continuous function. Symmetry is even. And it is, in fact, bounded from below. There are no asymptotes for this function. Pause the video and copy this down, and then move on to the next one. The cubic function. Domain is all real numbers, and I'll do it in interval notation this time. The symmetry is odd. It's unbounded. It's continuous. And I think that's all we basically, and there are no asymptotes. Next function, the square root function. Square root function is the domain is from and including 0 up to infinity. It's bounded from below. At y equals 0. There's no symmetry. And it's a continuous function. Now, this one is continuous wherever it's defined. So as long as you pick a value between within its domain, it would be continuous on its domain. Next function, the natural log function. We have an asymptote for this function at x equals 0. So you have a vertical asymptote. Okay, it's not bounded. You have a domain at the domain is on the interval from 0 to infinity. Notice I did not include I did not include 0 in that domain statement. And there's no symmetry. Next function is the rational function, y equals 1 over x. So the domain is negative infinity up to 0 and 0 to infinity. Other people would describe this domain as all real numbers, but x cannot equal 0. So it would be x such that x cannot equal 0. Symmetry, you guessed it, odd. It's not bounded. And it's continuous wherever it has its domain. So I'm going to say continuous on its domain. That means that it's not continuous at 0. And there's a vertical asymptote at x equals 0. And there's a horizontal asymptote at y equals 0. So it has horizontal and vertical asymptotes. Next function, the exponential function. Okay, so it's domain, all real numbers. It's bounded from below, y equals 0. It's got a horizontal asymptote at y equals 0. I'll draw that in red. No symmetry. And it's continuous everywhere. Next function, the sine function. The sine function has a domain of all real numbers. Its range is between 1 and negative 1. So it goes from negative 1 up through 1. It's got odd symmetry. It's continuous. And it's bounded from above and below. The cosine function is very similar to the sine function, except its symmetry is even. Now, you're going to need to graph this function, both of these functions, accurately. So you should take note on how the function starts and how it progresses. The value for which sine crosses through the x-axis is at 3.14, and it meets up again at 6.28. Here, it's at its highest at 0. It's at its lowest at 3.14, and it's the radians, and it's at its highest again at 6.28. So you have to make special notes as far as how to graph this function. Again, it's also continuous, and it's bounded in the same way that sine was. The absolute value function. Domain is all real. It's continuous. It's even symmetry. it's bounded from below by y equals 0. Um, that's basically it. No asymptotes. And I think we captured everything on that one. The greatest integer function. Domain is all real. It's not bounded. It's basically, I'll explain in class what the function is all about, but if you have a number, if you put a number into this greatest integer function, let's say the way it works is if you say the greatest integer of 7.835, it just basically cuts off all the decimal place and makes the answer 7. So if you're at like 3.5, the answer to this question is 3. So it's a specialized function, and so just understand that domain is all real numbers, and it looks like a series of steps. The logistic function is another function that is, it's got a domain of all real, but it's got no symmetry. It's used for modeling biological systems. It's got the S growth curve, or carrying capacity curve, if you know anything from biology about those topics. And it's bounded from above and below. So we're just going to say bounded by y equals 1 and y equals 0. Okay, the lower bound would be 0, the upper bound would be 1, and it's a continuous function as well. So you should be able to graph any one of these functions when asked to, and represent all of these questions as far as domain, continuity, boundedness, asymptotes. Oh, I'm sorry, on this one here for logistic, I nearly forgot. There's a horizontal asymptote at y equals 1. Now, if you look below here, there's a Quizlet which actually has the functions drawn and the names of their functions that was made by some other teacher or somebody in the math field. And I did a Google search on it. So if you click on the link, hopefully, if I can click on the link, maybe the link isn't active from this spreadsheet, but if you click on the link, it should take you to Quizlet, where it goes over the 12 basic functions. And you can see here that they have, that you can make flashcards out of these, and I'm sure you're all aware of what to do with Quizlet, but give it a try. Maybe you can print them out, and then, but you should be able to, for a quiz or test, answer all these questions that we talked about in the video. I'm sorry if the video went a little bit over on time, but I'm looking forward to hearing your comments, and hopefully you have a chance. You should have these written down in your notebooks or have them on your Evernote notebook. Anyway, have a good day, and see you tomorrow.